So in example 3, we've got IQs which are normally distributed, and we're asked to find the probability that a random adult is in this genius classification where their IQ is greater than 140. So the first thing I'm going to do before I answer this question is I'm going to write down what's the mean, what's the variance, and what's the standard deviation of this normal distribution. So the first parameter tells me what the mean is, which is 100, and the second parameter tells me that the variance, which we've been calling sigma squared, is equal to the second parameter here, which is 15 squared. So the standard deviation, which would be sigma, is the square root of the variance, which is 15. So let's draw a little sketch of what this distribution looks like, and then we'll try and work out this probability that we're asked to find. So we know that in the middle of the distribution is 100, and we're asked to find what's the probability that someone achieves this genius classification. Well, they're genius if their score is more than 140. So we want to work out the probability that x, this random variable x, is greater than 140. So let's put 140 on our diagram, and we want to work out what's that probability there of being to the right of 140. Now, you might know that IQ tests, the score can't go beyond a certain amount, but that doesn't matter because this graph is going to go really, really close to the x-axis really quickly. So it doesn't matter about the fact that it goes on forever to infinity, because these probabilities down here are going to be negligible. So let's go to our calculator, and we're going to use mu as 100 and sigma, the standard deviation, as 15. So mu is 100 and sigma is 15. And we're going to put our lower as 150, because that's where we want to start the area, 140, sorry, and our upper as a really big number, because we want to shade in, we want to work out the area all the way up to the end of the distribution, or as far as we can. So we get that's a really small probability, 0.00383. In part B, 20 adults take the test. Find the probability that 2 or more are classified as genius. So this is the probability of a random person being genius. So what we're doing is we're sampling 20 adults, and we're asking each adult to take this test, and they're going to be either be genius or not genius. So let's define a random variable. Let's say n is the number of geniuses, genius test scores, out of a sample of 20 people. Now, you should be able to recognize that this is actually a binomial distribution, because what we're doing is we're basically doing 20 trials and we're counting how many successes we have, where success is someone being a genius. So n is a binomial distribution, and we're doing 20 trials, and the probability of success on each trial is the probability that a random person gets a genius test score, which we've worked out in part A as 0.00383. So what this question is asking us is find the probability that 2 or more are classified as genius. So that's basically asking us what's the probability that n is greater than or equal to 2, because n is the number of genius test scores out of these 20 people that we're sampling. So we can actually use our calculators to work this out, and it's a binomial problem now. So if we go to our calculator, if we go to distribution and binomial, we want CD. Our lower, we want 2 or more. So we're going to put our lower as 2 and our upper as, well, we want to count up all the probabilities of having 2 people, 3 people, 4 people, 5 people, all the way up to 20 people being geniuses. So we can put our upper as 20. We're doing 20 trials, and the probability of someone being genius is this, 0.00383. And we can work out that probability, it's 0.00266.